Module 5, Configuring and Managing Virtual Networks. VMware ESXi networking features enable virtual machines to communicate with other virtual and physical machines. It allows for the management of the ESXi host. It also allows for VM kernel communication on the network. Failure to properly configure your ESXi networking can negatively affect virtual machine management and storage operations. There's 3 lessons in this module. Lesson 1, Introduction to vSphere Standard Switches. Lesson 2 is Configuring Standard Switch Policies. And Lesson 3 is Introduction to vSphere Distributed Switches. Lesson 1, Introduction to vSphere Standard Switches. After this lesson, you will be able to describe the virtual switch connection types and describe the components of a standard virtual switch. Types of virtual switch connections. A virtual switch has 2 main connection types to host and virtual machines. They can connect virtual machines to the physical network, and they connect VM kernel services to the physical network. A VM kernel service is the IP storage, such as NFS or iSCSI, or VMware vMotion, which allows you to migrate machines across the network or management network to the ESXi host. So a VM kernel allows operations of the ESXi client over that. A virtual machine connection is more or less, it's just a port group. It does not have an IP address. It just groups it together for VLANs, let's say. More of it's going to allow these machines to be a part of this VLAN or this port group, to whereas a VM kernel is actually used, such as for storage is the best one, or vMotion. Now also the management port on an ESXi host, for that's a VM kernel, there'll be a checkbox and you check it for use this for management. It's also how, if you ever have to use SSH to get into it, you will be doing that over the management port. You use the vSphere client to access the ESXi host directly. All that takes place over the management port. The VM kernel for vMotion, you will use that to do live migrations of machines to other hosts. And like I said, you can have these virtual machine port groups. You can have one called DMZ, and your virtual servers that are part of your DMZ will go into that group. A test dev group, have them go out to those virtual machines that are test dev, and then your productions. Virtual switch connection examples. You can have more than one network coexist on the same virtual switch, or you can break up your networks on the separate virtual switches. This top example right here, we have a virtual switch that's using one virtual switch and multiple networks coexisting on that switch. Such as we'll see, we got our vMotion here, our management here, production, test dev, and our iSCSI. Now, how this happens is we would have a VLAN for this, a VLAN for that, a VLAN for that, and each one in best practice would have its own VLAN. That way they are separate from one another physically on the network, and then virtually we'll tag it to be in its own VLANs. Now if we have, this cuts down on the actual amount of ports you see right here. This is on the host. So this cuts down on actually how many physical ports we have on the host. Now if we have just a bunch of ports and for some reason, some PCI or whatever regulation we're in, we have to separate them, we would need to get more ports. But as you can see here, it's broken out. We have our management, and we have 2 for redundancy. It has its own virtual switch. vMotion has its own virtual switch with 2 physical host ports production has 4 on here, but again, 2 physical. Our test dev, 2 physical. And then our iSCSI, 2 physical. As you can see, the physical will have 2 here. That gives us 4, 6, 8. We need 10 ports, whereas up here we only need 4. Types of virtual switches. A virtual network can contain these type of virtual switches. Standard switches. These are virtual switch configurations that are at the host level, the ESXi host. Distributed virtual switches. These are virtual switches that provide a consistent network configuration for virtual machines as they migrate across multiple hosts. This switch, a distributed switch, lives in vCenter. So think of it like this. We have our vCenter box. And then we have our host here, and we have a host here. And let's say inside of here we have created our distributed switch 1. All right, what happens, we configure port groups, VM kernels, what have you in this switch. What happens, this gets replicated down to each host and it has its own standard switch. These port groups will remain the same across this environment. If we had another host brought it into our vCenter, he will automatically, host 3, would get that switch configuration. And this stays, you can't see it, but this switch stays internally to the ESXi host. Reason for this is if vCenter for some reason went down, or I took it down for maintenance, I just need to update it, and it's gone, my networking still works across my hosts. I just can't make any changes. So that's a big difference between a standard and a distributed switch. Is distributed switch is housed in vCenter, and when we make a change, let's say we need to add a new VLAN. I want to add a VLAN 20. I'm gonna have web servers in it. The problem is I have to add a port group with that VLAN tag to each one of my local switches on my ESXi host, because if I vMotion that machine over to another one, it's got to have the same network so it lines up to the physical network so I can get connectivity. Well, that's all and good. I'll go here and I'll create the port group with the VLAN to each one of them. But what if I had hundreds of hosts, or even 10 would be a pain. This is where it's beneficial to have a distributed virtual switch. I would go in here and add my port group and tag it on the VLAN I'm looking for. Then what happens, it goes out to all my hosts. I had to configure it one spot. Standard switch components. Standard switch provides connections for virtual machines to communicate with one another, whether they're on the same host or on a different host. As we can look at this slide right here, the first configuration right here, you can see it's a standard switch with a single outbound adapter, which means it's ESXi. In the ESXi host, this is the bound adapter. It's bound to this physical that goes out to the physical switch. You can see the VLANs here. And as we can see, there's only one VNIC here for this virtual machine, and it is part of that virtual switch. So he's the only guy using this virtual switch. All right, for VM number 2, we have this virtual switch here, virtual switch 2, I guess I should say. It has a VM NIC applied to it. It has no outbound connection to the real world. See, there's no path here to go out to physical. But it's also sharing this. We got this VM NIC here in VM3 that's hooked into this switch. Okay, so what can happen here is only VM2 and 3 can communicate. All right. The third switch right here, we see it's got two. They're set up in a team for failover. So if this physical one goes out, this guy's still got connectivity. Now, he can't communicate with nobody but VM2. And he's got two adapters. So what I'm guessing in this scenario, what you could do, if you were talking to VM3 with this NIC, you need to talk to VM2, is you could do some sort of NAT right here, and traffic would come in through this physical to that virtual switch, which would then hit that NIC on VM3, and it would have to know how to route or whatever to route over to VM2, and VM2 would talk out, sort of like a little firewall or web proxy. And then when it gets to here, it would use either one of these based on the load or if availability of the physical network card on which way it would go from there. But as the example showing, VM3 can talk to the outside world from that NIC, can only talk to two from that NIC. Alright, our fourth one here is IP storage. So this is going out to nice SCSI, NFS, array possibly, just some sort of IP storage, and this will be connected into that network for whatever type of SAN is living on this network. And as you can see, it's on its own physical switch as well. Then we also, on switch number 5, have our management network. This will go out so our IT can manage the ESXi host, and it has its own physical server as well. Or physical switch, sorry. Its own physical switch, so IT can have it for management. And this is showing management VLAN 104. IT would be on that VLAN. This is just a security thing, so none of these other VLANs will be able to get to the management physically. Viewing the standard switch configuration, you can view a host standard switch by clicking on the networking on the manage tab. So you click on the ESXi hosts, then on the manage tab, and then on networking, and you can see our virtual switches. These are our switches right here. Of course, so that one distributed virtual switch. When we click on the virtual switch, we'll see more properties about how it's actually, this is the physical adapter right here that's on the ESXi host, and this is where we create our virtual machine networks that hook into it. Look, this one's called production, this port group. These are the machines associated with the production port group. We can delete the virtual switch configuration right there. And this is kind of neat. It helps in a data center, especially when you got a lot of wires, is if I want to know what port physically that's plugged into on the physical data center and I have a Cisco switch, if I click right there, it'll tell you the Cisco switch name and what port you're physically plugged into. ESXi supports 802.1q VLAN tagging. Virtual switch tagging is one of the tagging policies supported. Packets from a virtual machine are tagged as they exit the virtual machine, and packets are untagged as they return to the virtual machine. Effect on performance is minimal. ESXi provides VLAN support by giving a port group called a VLAN ID. So when you go in here and you create your port group, right here you give it the label, you'll have a drop down on the VLAN ID, and you'll have an option to type it to. You can say if your VLAN ID on your physical network is 2, you give it 2, and then when it sends out the physical, this network, it preserves the tag to the physical switch. So the physical switch picks it up, knows which VLAN it's going to put it in at the physical level. Network adapter properties. A physical adapter can become a bottleneck for network traffic if the adapter speed does not match application requirements. So here we can look at the physical adapters. I'll go to the ESXi host, go to manage, and then go to networking. We'll see on our physical adapters, these are the VM NICs on each that's on that host and what switch it's assigned to. We can do an edit on it if we want to change like the speed or make it auto negotiate, what have you. That's how we can, you can't do too much to it. That's how you can change stuff with the physical adapter. You should now be able to describe the virtual switch connection types and describe the components of a standard virtual switch.